Hello friends, today we will talk about warp drive in our series Faster Than Light Travel. So, first let us understand what warp drive stands for. Warp means bending or twisting. So we can say that warp drive talks about faster than light travel by warping space-time fabric. So, now you must be questioning what is spacetime fabric. Spacetime can be thought of as fabric or a sheet in which the objects are placed. If the object has some mass, it will bend the space accordingly. More specifically, positive mass bends the fabric downwards and negative mass bends the fabric upwards. Now, to understand warp drive, we need to understand another concept called special theory of relativity. According to it, you need infinite amount of energy to accelerate an object to speed of light. So no object with mass can travel faster than light. In 1929, Edwin Hubble confirmed that galaxies are moving away from each other. The interesting thing is that galaxies are falling apart faster than light. It seems to be breaking the Einstein's theory of special relativity, but it is not. Einstein's theory of special relativity only applied to objects in space, not to space itself. To understand warp drive, we take a slinky spring, consider it as space. We have Earth as our starting point and a star as our destination point. Now we expand the space behind our spaceship and contract space in front of us. We are already at our destination. Our spaceship will be safe and we don't experience any time dilation. As we are not moving, it's the space which is moving. Let us take another example. Suppose we are surfing on a wave. Here we are not moving, it's the wave which carries us forward. Similarly, it's the space which takes us to destination. We are protected in bubble. Now we understood how warp drive works. Now let us see what is required to make such travel possible. First of all, we need a lot of positive mass to bend the fabric of spacetime. Accuber estimated that warp drive with a 100-meter bubble would require the mass of entire visible universe. It was brought down to mass equivalent of Jupiter by continuous hard work of scientists over past years. Secondly, we need negative mass which will warp space fabric upward. Negative mass is very weird. If we throw a ball away from us, it will come towards us. We know that gravity attracts a positive mass object, but it will repel negative mass object. So negative mass will always move away from us. Thus we have not found any negative mass yet. We have also observed negative mass at quantum level in Casimir effect, but the amount we get is very small. Now, let us understand the problems in warp drive. To create this bubble, we need exotic matter and hypothetical energy generator to output energy equivalent to Jupiter's mass, which is 10 trillion joules, and to compress it so it can fit in our spaceship, and also not too dense to form black hole, which seems very hard at this time. Quantum physics has also something to say about our dreams of zipping through space-time faster than light travel. It's the Hawking radiation. It would most likely cook anything inside this theoretical bubble anyway. The person in the center of the bubble in a warp drive will experience a thermal flux of Hawking particles. On the other side, such Hawking flux will be generically extreme high if the exotic matter supporting the warp drive has its origin in a quantum field, satisfying some form of quantum inequalities. In short, Hawking radiation will be generated, irradiating the occupants of the bubble to a very high temperature. To be precise, Hawking radiation predicts to roast anything inside the bubble to a possible temperature of 1 million trillion Kelvin. This is it for today. We will meet in our next episode of Faster Than Light Travel. Till then, keep hope, keep dreaming.